Okay, greetings everybody. New video. Hopefully everyone's going to watch this. Okay, let's review our log rules. Okay, notice I've got a log with a base A, and I'm inputting A. Okay, and the exponents are, if your base and the input are the same, the answer is the exponent. Okay, this is basically, this says what's the exponent that A is raised to get A to the R. Well, it's obviously R. Okay, and remember, all right, so notice that this base and this are the same. Okay, the input that you're plugging in are the same. Okay, this is also another one that's going to make this become true in another fashion. Is let's take a look at the second exponent rule that says we can move this exponent down in front of the log. Log base A of m to the R power, we can move that R in front, the exponent in front, and it can be R log A to the m. We can do the same thing here and move that R, and what is the exponent that A is raised to get A? 1. So anytime log of 2 of 2, log base 2 of 2, log base 3 of 3, that's just 1. What's the exponent that A is raised to get A? 1, and R times 1 is just R, okay? So those are two rules here that kind of coincide in a way. All right, so anytime you have an exponent, that can come down in front, okay? Anytime your base and the input are the same, the answer is the exponent. We've gone over this a bunch. Anytime you have a log of some base of two factors, like m times n, they can be rewritten as the sum of the individual logs of each factor. Log base A of m plus log base A of n is the same as log base A of m times n. Log base A of m divided by n equals log base A of m minus log base A of n. Okay, when you have division, it can be rewritten as the individual logs of each of the dividend and the divisor. Okay, you just subtract them, just because remember, when you divide like bases, you subtract the exponents. Okay, all right. Here's another one we have. Let me zoom in here a little bit. When I've got a base and the exponent is a log, this is the natural log, your answer is just whatever you're taking the log of. Remember, this is basically, natural log is base e. So this says, hey, what is the exponent that e is raised to get 3? Well, I'm raising e to that exponent, so my answer is 3. That's the important point, is the base and this base are the same. Here's another example. 7 to the log base 7, notice these are the same, log base 7 of 10. This says, what's the exponent that 7 is raised to get 10? Well, if I raise 7 to that exponent, I get 10. Okay? Like I said, anytime you have log base 2 of 2, that's 1. Log of anything, log of 1, I don't care what your base is always 0. Okay. Let's practice now another skill, rewriting a base to like a prime number. Let's say we can rewrite 8 to the third power. We can rewrite 8 as 2 to the third power. Okay? So it's really 2 to the third power to the third power. So remember our rules for raising a power to a power. You multiply the exponents. This would be 2 to the 9th. So 8 to the third is also 2 to the 9th. Okay? Remember about what negative exponents do. 1 over 64 can be rewritten as 1 over 4 to the third power, because 4 times 4 times 4 is 64. And I can rewrite that as 4 to the negative third. Okay, so 4 to the negative third is 1 over 4 to the positive third, which is 1 over 64. We're going to use that later in the lesson. Okay? All right, so first thing we're going to do tomorrow is we're going to solve these problems by just converting everything to a like base. All right? Here I've got 4 to the 1 minus, that's an x, 1 minus 2x equals 64. Okay? Well, let's rewrite 64 so it's the same base. Okay? So 64, this is something you guys are going to just have to know your factorizations, but 4 to the third power is 64. So now I've got 4 to the 1 minus 2x equals 4 to the third power. Okay? All right? Well, obviously, if this equals this, and my bases are the same now, the exponents have to equal each other. 1 minus 2x needs to equal 3. Okay? I don't know if you can see that. It doesn't look like it's showing up very well. Okay? All right. There we go. There's showing up a little better over here. Okay? So 1 minus 2x equals 3. So I just use algebra now. I subtract 1 from each side. I have negative 2x equals 2. Okay? And then we're just going to divide. Obviously, I have to get this. I divide negative 2x by negative 2. I do both sides, divide both sides by negative 2, and I get x equals negative 1. Okay? So just convert this so it's the same base, so your exponents have to equal each other. That's the key. Okay? Recognize that 64 has a base of 4. Rewrite it. Now you have the same base, so obviously the exponents equal each other. Okay? Here's another example of a little more complicated. Here's 27 and 81. Notice I know 27 is 3 to the third, and 81 has a base of 3 to the fourth. So this is going to be 3 to the 3x plus 2, and this is 3 to the 4 to the 2x minus 3. Remember, when you raise a power to a power, I'm going to multiply exponents. So that'll be, again, my exponents need to equal each other because my bases are the same. If this equals this, then obviously 3 to some power equals 3 to some power, then these exponents need to equal each other. Well, what are the exponents? Remember, we have to multiply this times this and this times this. Okay? So 3 times 3x plus 2 equals 4 times 2x minus 3. Okay? Distributive property, 9x minus 6 equals 8x minus 12. And just algebra. Subtract 8x from both sides. And I've got x plus 6 equals negative 12. And then I subtract 6 from both sides, and I get x equals negative 18. Okay? So again, a little more complicated, just a little more work involved. All right? Now, we're going to solve by using logarithms, okay? First thing we're going to want to do here, I've got 10 times 3 to the 3x power equals 96. Let's get our base and exponent by themselves, okay? So in this case, all I have to do is divide both sides by 10, okay? So this 10's cancel out, and 96 divided by 10 is 9.6, okay? So I have 3 to the 3x equals 9.6, all right? Notice what I'm going to do here. I can't make this a like base. I'm going to take the log, the natural log or common log, it doesn't matter. I'm going to take the natural log here of both sides, okay? What that does for me, it brings this exponent in front using the exponent rules, okay? So now I've got 3x, I move this out front, 3x times log of 3 equals natural log of 9.6, all right? I want to get this by itself, so what am I going to do? Just go ahead and divide both sides, okay? For some reason, it just doesn't seem to be, I hope you can see this, guys, okay? All right, so I divided both sides by log of 3. And notice this time this is a log of 9.6 over log of 3. Okay, so if I do this, maybe you guys can see this. I'm going to control divide, so I get that fraction bar. Okay, and I'm going to do right here, let me see, so you can see. Control this e to the x, there's my log. Okay, and I'm going to put in 9.6 over, again, control e to the x, get that log. Okay, so, and I'll put in here, so you can see this. What do we divide? 9 divide by 3, all right? Okay, so I want log of 9.6 over log of 3. Okay, and I get 2.0587. Okay? And that's what we just did. But that's 3x equals that, so I divide both sides by 3, and I get this 0.686. Okay? So what do we do here? We're going to solve by taking the log of both sides, but first we want to get just the base by itself. So divide or subtract and use your algebra to get the base with the exponent by itself. Okay? And then you take the log, and I've got a base exponent equals this. I took the log of both sides. That brings the exponent down, and we just divide out. Okay? So we'll get a little more in depth with some adding and subtracting, and not just dividing, but it'll be the same basic thing of taking the log of both sides to get the exponent down. Okay? That's 10 minutes. This should get us started for tomorrow, everybody. I look forward to seeing you. Okay? Take care.